In this video, we will solve exercise miscellaneous 7. Question number 1. How many words with or without meaning, each of having 2 vowels and 3 consonants, can be formed from the letters of the word daughter? So in the word daughter, number of vowels, one, two, three, 3 vowels. Number of consonants, 5. Now you are to select 2 vowels and 3 consonants, and then you will arrange these 5 objects. So first, number of selections of 2 vowels out of 3, it will be 3C2. 3 factorial upon 2 factorial, 1 factorial, finally it will be 3. Ways of selection of 2 vowels out of 3, this is 3. Second, number of selections of 3 consonants out of 5 consonants. It will be 5C2. It means 5 factorial upon 3 factorial, 2 factorial, it will be 10. So total number of different combinations having exactly 5 letters. So number of combinations having 2 vowels and 3 consonants using fundamental principle of counting, it will be 3 into 10, 30. It means we have 30 different combinations, and out of these 30, each one has 5 objects, and we are to answer how many words are possible. And in case of formation of words, order is important. Now the question is, in how many ways can you arrange each combination out of these 30? Each combination has exactly 5 objects or 5 letters. So number of arrangements for 5 letters, number of arrangements for each combination, it will be 5p5 or 5 factorial, that is 120. We have 30 different combinations, and each combination can be arranged in 120 ways. Therefore, number of words using fundamental principle of counting is number of combination into arrangement for each combination, that is 3600. Now next question is question number 2. Second question. How many words with or without meaning can be formed using all the letters of the word equation at a time, so that the vowels and consonants occur together? It means all the vowels are together and all the consonants are together. They are not in a scattered way. So in the word equation, number of vowels 5, number of consonants 3. Yes, it has 3 consonants and 5 vowels. Now as all the vowels are together, it means vowels A, E, I, O, U can be internally rearranged. Similarly, consonants Q, T, N can also be internally rearranged. These 5 objects can be rearranged in 5 factorial ways. These 3 objects can be rearranged in 3 factorial ways. So, number of arrangements 4, 5 vowels is 5 factorial 5p5. Similarly, number of arrangements 4, 3 consonants 3p3 or 3 factorial. And these two groups of vowels and consonants can also be rearranged in 2 factorial ways. Vowels and consonants, or first consonants and then vowels. Groups of vowels and consonants can be arranged in 2 factorial ways. Therefore, number of words equal arrangement of vowels into arrangement of consonants into arrangement of these two groups. 12, this is, yes, 1, 4, 4 and 0. This is second question. Next is fourth question. If the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? Question number 4. In the word examination, number of letters 11, and there are some similar letters. First is A. Now number of A is 2. A is 2 times. Number of N's or number of I's 2. Number of N's 2. We have total 11 letters having 2A, 2I and 2N. And how many words will be in the dictionary before the first word starting with E? If we are asking about in the sequence of dictionary, it means it will be an alphabetical sequence. So there will be, first there will be words, starting with A. After that, words starting with E, then words starting with I, and so on. Now find out number of words before the first word starting with E. It means simply question is find out number of words starting with A. So number of words before the first word starting with E equal number of words starting with A. Now if you want to write number of words starting with A, it means first place has been fixed. You have no option for this place. It will always be filled by A, and remaining 10 places can be filled with your choice. 10 places. In how many ways can you fill up these 10 places? Using remaining 10 letters. It means you have, out of these 10, you have 2N, 2I and a single A, as one A has been used at this place. So find out number of arrangements of 10 objects at 10 places having 2 identical I and 2 identical N. So number of arrangement equal number of arrangement for remaining 10 places, and it will be 10 factorial upon 2 factorial 2 factorial. You can simplify it, and finally answer will be 907200. 907200. Next, question number 7. Seventh, in an examination, a question paper consists of 12 questions divided into two parts, part first and part second. Question paper consists two parts, part first and part second. Part first and second containing 5 and 7 questions respectively. Number of questions available. In part first, it is 5. In part second, it is 12. This is the number of questions available, and a student is required to attempt 8 questions in all, selecting at least 3 from each part. In how many ways can a student select the questions? Now restriction is he is to select total 8 questions having at least 3 questions from each part. So ways of selection. Ways of selection: he can select 3 questions from first part and remaining 5 from second part to complete 8 questions, or 4 questions from first part and 4 questions from second part, or 5 questions from first part and 3 questions from second part. He cannot select 2 and 6 as he is required to attempt at least 3 questions from each section. Now number of selections. Number of selections of 3 questions out of 5 it will be 5C3, and selection of remaining 5 out of 12C5, and these 3 questions with these 5 questions, so multiply these numbers using fundamental principle of counting. Selection of 4 out of 5 is 5C4. Selection of 4 out of 12, sorry, second part is, this is questions are 5 and 7, this is 7, correct it, 7C5. Total 12, having 5 and 7. Selection of 4 out of 7, 7C4. Similarly, selection of 5 out of 5 is 5C5, and selection of 3 out of 7, it will be 7C3. So total number of ways of selections, he can choose either in this way or in this way or in this way, either first way or second way or third way. First with second नहीं है, either first or second or third, any one out of these 3. So total number of selections is 5C3 into 7C5 plus 5C4 into 7C4 plus 5C5 into 7C3. You can simplify these numbers and finally you will get 420. In 420 ways he can select the questions. Next is question number 9. It is required to seat 5 men and 4 women. 5 men and 4 women in a row so that the women occupy the even places only. How many such arrangements are possible? There are total 9 members, so it means you are to fill up these 9 boxes. 3, 4, 5, 6, 7, 8, 9. Women can occupy even places only. These are the places available for women, 2nd or 4th or 6th or 8th. It means 4 women can sit at 4 places. In how many ways? So number of ways to sit for 4 women. Arrangement of 4 at 4 places, obviously 4p4 or 4 factorial or 24. Remaining places 5. Remaining members, that is male members, available 5. So arrangement of remaining 5 at remaining 5 places. Number of ways to sit for 5 men. It will be 5p5 or 5 factorial or 120. So total number of arrangements, these 4 ladies and these 4 with these 5 male members, first with second, so first into second, and it will be 2880. You can calculate it. Next is question number 10. This is the, I think this, yes, 10th question. From a class of 25 students, 10 are to be chosen for an excursion party. Selection of 10 out of 25 with certain restrictions. There are 3 students who decide that either all of them will join or none of them will join the party. In how many ways can the excursion party be chosen? Case 1. If all of the 3 join the party. If each one of these 3 students join the party, then number of arrangements. As there are total 25 students, and out of these 25 you are to select exactly 10, but 3 have confirmed that they will join certainly. It means you have choice for selection of 7 students only after these 3, and out of 22 students. So it is not arrangement, it is selection. Number of selections of remaining 7 out of remaining 22, as these 3 will obviously join, will certainly join. So selection of remaining 7 out of remaining 22. In 22 see 7 ways. Case 2. If none of the 3 will join, if none of them will join the party, it means you have no choice for these 3 students. Once again, you are to choose total 10 out of remaining 22. Then number of selections equal selection of 10 out of 22, as these 3 will not join. Exclude these 3, remaining options available 22, and to be selected 10. It means either you can select in this way or you can select in this way, either this or this. So total number of selections equal 22C7 plus 22C10. This is the answer. Thank you. Keep on watching my videos. Thank you.